Exercise 2.1, Question 1. Look at the graphs of y equals p of x and find the number of zeros of p of x in each case. The key concept to remember throughout this question is the number of zeros of a polynomial equals the number of times its graph touches or crosses the x-axis. Every point where the curve meets the x-axis corresponds to exactly 1 zero. We are shown 6 separate graphs, each displayed one at a time with its own coordinate axis. Let us go through them one by one. Graph I shows a horizontal straight line that runs completely above the x-axis. The line never touches or crosses the x-axis at any point. Therefore, the number of zeros is 0. The polynomial has no real zeros in this case. Graph 2 shows a cubic-shaped curve. Observe carefully, the curve crosses the x-axis at 3 distinct separate points. At each crossing point the curve passes through the x-axis from one side to the other. The number of zeros is 3. Graph 3 shows a parabola, a U-shaped quadratic curve. The parabola crosses the x-axis at 2 distinct points, one on the left and one on the right. The number of zeros is 2. Graph 4 shows a parabola that opens upward and sits entirely above the x-axis. Like Graph I, it never makes contact with the x-axis. The number of zeros is 0. Graph V shows a parabola whose lowest point, the vertex, sits exactly on the x-axis. The parabola touches the x-axis at this single vertex point and immediately curves back up without crossing. This is a repeated zero, also called a zero of multiplicity 2. The number of zeros is 1. Graph 6 shows a higher-degree polynomial curve that moves up and down in a wave-like pattern, crossing the x-axis at 4 distinct separate points. The number of zeros is 4. Summary of all 6 cases. Graph I gives 0 zeros, Graph 2 gives 3 zeros, Graph 3 gives 2 zeros, Graph 4 gives 0 zeros, Graph V gives 1 zero, and Graph 6 gives 4 zeros. These answers correspond directly to what is visible on each graph. Exercise 2.2, Question 1, Part 1. Find the zeros of x squared minus 2x minus 8 and verify the relationship between the zeros and the coefficients. Step 1. Write the polynomial and identify the coefficients. P of x equals x squared minus 2x minus 8. Here A equals 1, B equals negative 2, and C equals negative 8. Step 2. Factorize by splitting the middle term. We need two numbers whose sum equals negative 2, the coefficient of x, and whose product equals negative 8, the constant term. We try the pair negative 4 and positive 2. Negative 4 plus 2 equals negative 2 and negative 4 times 2 equals negative 8. Both conditions are met. Now we split x squared minus 2x minus 8 equals x squared minus 4x plus 2x minus 8. Grouping x times x minus 4 plus 2 times x minus 4. Factoring out. The common bracket gives x plus 2 times x minus 4. Step 3. Find the zeros. Setting p of x equal to 0 gives x plus 2 times x minus 4 equals 0. So either x plus 2 equals 0 giving alpha equals negative 2, or x minus 4 equals 0 giving beta equals 4. Step 4. See the parabola on the graph. The curve y equals x squared minus 2x minus 8 opens upward and crosses the x-axis at x equals negative 2 on the left and x equals 4 on the right. Both zeros are clearly visible. Step 5. Verify the sum and product. Sum of zeros, alpha plus beta equals negative. 2 plus 4 equals 2. Negative b over a equals negative 2 over 1 equals 2. Sum is verified. Product of zeros, alpha times beta equals negative 2 times 4. Equals negative 8. C over a equals negative 8 over 1 equals negative 8. Product is verified. Both coefficient relationships hold correctly. Exercise 2.2, Question 1, Part 2. Find the zeros of 4s squared minus 4s plus 1 and verify the relationship between the zeros and the coefficients. Step 1. Identify the coefficients. P of s equals 4s squared minus 4s plus 1. Here a equals 4, b equals negative 4, and c equals 1. Step 2. Recognize the special structure. Look at the expression 4s squared minus 4s plus 1. Notice that this is a perfect square trinomial. We can write it as 2s minus 1, the whole expression squared. To confirm, 2s minus 1 squared equals 4s squared minus 4s plus 1. Yes, this matches exactly. Step 3. Find the zeros. Setting 2s minus 1 squared equal to 0 gives 2s minus 1 equals 0, which means s equals 1/2. Since both factors are identical, alpha equals 1/2 and beta equals 1/2. This is a case of a repeated zero. Both zeros of the polynomial are equal to 1/2. Step 4. See the graph. The parabola y equals 4s squared minus 4s plus 1 opens upward and its vertex rests exactly on the s-axis at s equals 1/2. The parabola touches the axis at this single point and does not cross it. This confirms 1 repeated. 0 at s equals 1/2. Step 5. Verify. Sum of zeros, alpha plus beta equals 1/2 plus 1/2 equals 1. Negative b over a equals negative 4 over 4 equals 4 over 4 equals 1. Sum is verified. Product of zeros, alpha times beta equals 1/2 times 1/2 equals 1/4. C over a equals 1 over 4 equals 1/4. Product is verified. Both relationships are confirmed.